Hey everyone, in this tutorial we're going to take a look at using SQLite as our database in a NativeScript Angular 2 application. So if you've been keeping up with my NativeScript material, you'll know that I've done a SQLite tutorial for NativeScript already. That tutorial was built for vanilla NativeScript, so NativeScript without Angular, and it even used JavaScript rather than TypeScript. So while that tutorial is still very valid, I know a lot of you would rather use Angular 2, myself included. So this tutorial should put you on the right path for getting started with a SQLite database. We will start by creating a new NativeScript project. We're going to do that on our desktop. I am using NativeScript 2.3.1, but this tutorial should remain pretty true for future versions as well. So let's go ahead and say tns create SQL project --ng. And then we're going to navigate into that freshly created project directory. So cd SQL project. And we're going to add some build platforms. So we're going to say tns platform add iOS. And we can also say tns platform add Android. Now it's important to note that if you are not using a Mac, you will be able to add the iOS platform, but you will not be able to build for it. You need a Mac with Xcode installed in order to build iOS applications. Android will work for pretty much any operating system. So let's go ahead and clear that. So this tutorial, just like the last one that I wrote on the subject, actually uses the same plugin. So this uses the SQLite plugin for NativeScript by Nathaniel Anderson. So we're going to add it like the following. So we're going to say tns plugin add NativeScript -SQLite. And now we're going to open up this project in whatever IDE we want to use. So in particular, I'm going to be using Atom, but you can use whatever you want. All right, so I do have the project open in my editor. Something to note, and it's not a showstopper here, but the SQLite plugin for NativeScript by Nathaniel actually has a free and a paid version. The free version does not have TypeScript type definitions. So that means that in an Angular 2 project which uses TypeScript, it's going to make things a little more complicated, but you know what? It's only going to slow us down. It's not going to stop us. So I'm going to show you how to get around that. Or if you want to support Nathaniel, definitely check out and see if his paid version makes sense for you. All right, so what we're going to do is we're going to do all of our work inside of the app component.html file and the app component.ts file. So starting with the TS file, the TypeScript file. Let's go ahead and clear out the app component class, and we're going to import that SQLite dependency. So because we're not using TypeScript, the import is going to be a little different. So instead, we're going to do it more like JavaScript. So we're going to say var SQLite equals require NativeScript SQLite. So we won't have any of the type definitions, so we won't have autocomplete or anything like that, but at this point it's actually very usable. So let's go ahead and now define our variables to be used with throughout this application. So we're going to define a private variable called database. It's going to be of type any. We're also going to define a public variable called people, and that's going to be of type array, and we're going to just allow it to be any. We're not going to get into the specifics there. The next thing we want to do is we want to make a constructor and actually initialize our database and establish a connection to it, even though that it's local. So we're going to say public constructor. And inside of the constructor method, the first thing we want to do is probably say this.people equals empty array. So we're going to initialize that, the simplest thing we can do. But we also want to say new SQLite. We want to say what database we want to open. And this could be whatever you want. I'm going to call it my.db. You can name it whatever you want, and you should be all right. And then we're going to say dot then. So we're going to use a promise here, and we're going to say db. And we're going to see what happens when this database is now created and opened. If for some reason it failed, so maybe there was an error, we can actually say error. And inside of here, we can say console.log. And in this case, we can say something along the lines as open db error, and then whatever the error is. So inside of our now open database, the first thing we probably want to do is we probably want to create a table if it doesn't exist. And by doesn't exist, I mean if it does exist, we're gonna ignore it and proceed as normal. So what we can do is we can actually say db.execute SQL, and we can pass in a SQL statement. So we're gonna say create table if not exists. We're gonna call that table people, and it's gonna have an ID, which is a primary. It's gonna be an integer primary key. And it's going to auto increment. We're going to have a first name, which is going to be of type text. We're going to have a last name, which is also going to be of type text. So with those added, we can now exit out of this statement here. And we're going to say then, and we're going to say ID, and then whatever the result of this particular statement is. But it really doesn't matter what the result of this statement is. Because all we care about is that it's one, it succeeded, and two, our database is still open. So we can actually say this.database equals DB. So we can now reference this.database throughout the rest of our application when we want to use the database. Otherwise, let's go ahead and say there was an error, and we can say console.log, and we can say create table error, and print it out. All right, so our constructor is good. We have our database initialized at this point. Now we want to worry about our insert or any kind of manipulation against the database, I guess you can say. So let's go ahead and create a function. We'll call this insert. And we'll also create another function, and let's call that fetch. So one for inserting data, one for fetching data. There's a whole lot more stuff when it comes to databases. But this should give you a general idea on how to really do this stuff on your own. So for the insert, what we'll want to do is we'll want to say this.database, because that's our open database, .execute SQL. Now we can go ahead and pass in a SQL statement. So we're going to say insert into people. We're going to insert a first name, a last name, values, and then this is going to be a parameterized query. So we're going to be using parameterization, so that way we don't have any kind of SQL injection attacks, and it's really overall a good idea to do. So we're going to pass in those parameters. This is going to be a very simplistic application, so I'm not going to be using dynamic data here, but if you wanted to, you would match these parameters inside of this array with those question marks. But for us, it's just going to be static data. So I'm going to say Nick Raboy. Remember, very easy to do if you want dynamic data, but I won't have an import form for this particular demo application. But we're going to say then, we're going to say ID. So this would be the row ID that gets returned from a successful insert. Otherwise, there was some kind of error, and we want to print it out. Console.log, insert error. We'll fix my typing mistake, and we'll display that error. If it was successful, what we really want to do is we want to really load the database if it was successful, but we're not quite there yet, so we'll leave it blank for now inside of the insert success. What we're going to move down to is now the fetch. So as far as fetching data goes, we're just going to select all data in the database, and our end goal is to display it in a list view. So what we want to do is we want to say this.database.all, and this was all found inside the documentation for the SQLite plugin. But we're going to say select star from people, then, and we're going to say rows, and then let's see if there was an error. And if there was, let's say console.log. We can say select error. Otherwise, what we really want to do is we want to populate that people array that we created previously. So the first thing we probably want to do is every time we fetch, we probably want to say this.people equals empty array. So we'll probably want to clear it out. But then we want to loop through our result set, because the result set, we do have to parse it. We have to really, I guess you can say, marshal it into a correct format. But we can say var, or we can say let row in rows. And now we can say this.people.push, and we're going to push in an object. So the object being first name. We could actually say ID because we do have an ID in there. So the ID will be rows, row, and then 0. And then say first name, rows, row 1. So this is the second column. And then last name, rows, row 2. So this is what we're pushing into that people object or people array. So we do have our fetch. So after we do an insert, now we want to call fetch, this.fetch on line 28. So we're now fetching. If we really wanted to, when our application loads, we can also do, we can call this.fetch as well. And it should work out pretty good. So now that our logic is in place, let's go ahead and check out our front end. So our UI, and inside of the UI is where we're going to have our list view and kind of all the front end action. So let's go into our app component.html. Let's clear out what's inside of the stack layout. You can leave the stack layout itself though. We're going to create an action bar. So we're going to say action bar, title equals SQL app. The action bar is going to have 2 buttons. You know what, for us, let's go ahead and add 1 for now. We may not need the second one. So we're going to say action item. We're going to say text equals add. We're going to say iOS.position equals right. So it's going to appear on the right hand of the action bar. And we're going to have a tap event. So the tap event will be insert. So remember, inserting should add data to the database and fetch afterwards. But we need a way to display it. So inside of our stack layout, we want to create a list view. So list view. And we're going to say items equal people. And inside of the list view, we're going to say template. So each row of the list is going to be inside of this template. We're going to say let person equals item. And we're going to have a label. This label is going to say text, and it's going to be, it's actually going to be person dot first name, and then person dot last name, and we're going to close it off. So in theory, this should work as of right now. So if I open up my terminal again, we're going to clear our terminal, and we're going to run the project. TNS emulate, I'm going to emulate it on iOS. All right, so the application is now open. So in theory, if we click add, my name should show up in this list. So let's go ahead and give it a shot. So I'm going to click add. And it did show up. You'll notice that it created extra rows. This is because I haven't styled my list view. In iOS, it's a little weird. It adds these like phantom rows, if you want to call it. It's an iOS thing. It's not a NativeScript thing. In Android, it would only show this one item. And this is easily corrected if you want to style it with CSS. But you just saw how to add items to this SQLite database using Angular 2 and NativeScript. For future though, it is a good idea to actually move all of this database code into its own provider. You probably don't want to leave it inside of your component. It's not good practice. It'll work better inside of its own provider. If you don't necessarily like SQLite, I do also have a tutorial floating around that uses NoSQL, which some would argue that it's better. Some would argue it's really a preference thing. But if you want to check it out, it's a Couchbase NoSQL tutorial for NativeScript and Angular 2. But this is a SQLite tutorial, and it actually worked out quite well.